So, hello everyone who is just joining in. We'll just start in a few minutes. I'm just going to check the stream. So, yes, I can see that the streaming is going good as for now. So, if any of your friends who wants to join in, they can join in right now. So, let me know if my voice is clear. So, let me know if my voice is clear, please. I hope that the voice you can hear correctly. Once let me check the voice as well. So, as I can hear that my voice is correct. So, welcoming you today for the stream. As we've mentioned that today's stream is about machine learning, intro to machine learning, basics of ML, importance of crowdsource, introduction to Raspberry Pi, Arduino, IoT, etc. So first of all, do let me know which college are you all from? So also do let me know if my voice is clear as well. Again, please. We'll just start the session in 5 minutes. We are just waiting for more people to join in. I hope you enjoy today's session and learn a lot. And in the follow-up sessions also, we'll continue this. There's also other sessions we've held on machine learning, and it's the first session we're holding on IoT because a lot of you guys requested on it. So I hope that you like today's session. We'll just start in a few minutes. We're waiting for a few more people to join in. Today's first session will be introduction to ML and the importance of crowdsource in ML, and we'll see the roles that crowdsource plays in ML, some basic tools of ML, which will be taken by Sachin Singla. He'll introduce himself in a minute.
Hi everyone.
Hi Shivam. So we'll just start in a few minutes. Sachin, sir, in the meantime, Sachin sir will introduce himself.
Yeah, sure.
So I hand it over to Sachin. Sachin, you can take over. Thank you. You can please present your screen as well.
Yes, thanks, Imant.
Yes, please continue.
Yeah, so hi everyone. Uh, I'm Sachin Singla, final year student pursuing bachelor's in computer science from Delhi Technological University. A brief intro about myself. I'm a former SG intern at Mintra. I've been Google Explore ML facilitator. I'm also currently facilitator for 30 days of GCP program, and I'm a Microsoft Learn Student Ambassador for 2 years for now, which was earlier known as Microsoft Student Partner. And I've been a Google Coding 19 mentor at TensorFlow. So today we'll be seeing about the basics of machine learning and the importance of crowdsource and how it is linked with machine learning. So let's begin. So, talking about the basic process in machine learning, we have these 5 steps. First, we should be knowing about our users, what the problems we are solving for. Then, the objective, we should be clear, and our vision should be clear in the starting of the project why we are doing this, why we need this. Then once we have the vision, we move to collection of data where we should have the right data sets which we'll be using to train our models. The next step is training and testing the models. And at the end, once we have created the models, we need to predict and evaluate our results if we are getting the correct results as per our expectations or not. So these are the five basic steps that we have in any machine learning project that you take on. So let's see what can ML do. So basically, many people have confusion in the terms artificial intelligence, machine learning, and deep learning. So this chart represents the interconnection between the three very clearly. That artificial intelligence is the broader term which talks about any smart system. Then in artificial intelligence, we have a subpart machine learning, which refers to training machines and giving them algorithms to work on. And in that, a specific part is deep learning, where we use the neural networks and very specific algorithms of machine learning to train the models. Now, many of you might have heard these terms commonly used in machine learning. This is classification, like for problems where we need to classify whether, if we are given an image, whether it is a dog or a cat, which class it belongs to. And this is what we mean by classification. Then we have regression. Say you want to predict the price of house and you have various parameters like location, weather conditions, previous neighborhoods, and so on and so forth. So there we have algorithms of a regression which would help us in predicting the house prices correctly. Then we have clustering, where like if you want to cluster similar things in one cluster, say as the image predicts, if you have seven written by different people and you want to figure out that all these belong to the character 7, so this forms a cluster of digit 7. Similarly, this forms a cluster of digit 2. Then sequence prediction, this is, you must have experienced it in your mobile phones when you are typing chats. It itself gives you the options as you type the initial characters of the words that you might be typing. So this is what we mean by sequence prediction. Say you want to type cat and you start with C A and it gives you suggestion that it could be cat, it could be cab, and so on. So this is what we mean by sequence prediction. Then we have style transfer, where say we want to convert from one language speech to text, or we want to convert from English to Hindi, and so on. All these come under the domain of style transfer. Now, once we have seen these types of machine learning, let's see some real life examples and try to find out where each of these would fit in. So, I would expect some answers in the chat here. Suppose you want to recommend what someone will download based on previous purchases. What do you think should be the kind of machine learning algorithm that we should be using to solve this problem? Whether it should be classification or clustering or regression or sequence prediction or style transfer. Rohit says clustering. So basically, this is an example of sequence prediction as we saw. So in sequence prediction, what we are taking care is seeing the previous history of how the consumer has been performing and then predicting. So like as we talked about the example of typing in mobile phone in chat, so it takes your previous words that you have typed and it gives you predictions according to that. So similarly, if we want to see what someone will download, we need to have a sequence prediction, like he has gone through these in the past, so this is what he must be downloading or viewing after this. Yes, Akash gave the correct answer, sequence prediction. So moving on, next we have labeling email as spam or not spam. What do you think should be the category for this? So basically, it is uh, definitely yes, Akash. It is a very common example of classification, which is commonly used in your email box as well. That is to classify your emails as spam or not spam. Then we have captioning a video. So suppose you are having a video playing on and you turn on the captions. So what do you think is being used there to caption the video? So this is an example of style transfer as told by Akash also. So this is where like we have the video, it is in one format, that is a video format, and we want it in text format, like what is being spoken should be captioned. So this is an example of style transfer. Next, we want to determine the workout activity based on phone movement. This is a bit tricky. So yes, Shivam answered it right. It is an example of classification. So suppose if the activity is very fast, it might make it as running. If it is slow, then it might be kind of jogging. And there might be different activity for kind of swimming and so on. So this is how we have to classify it in different kind of activities, which could be determined by the phone movement. Then this is a very classic example. So Rohit has a doubt, why not regression? So in regression, we could have answers like, so suppose you want to predict the price of a house, then the price could be 25 or 25.5 or 26. So in regression, we have a continuous output. But in say suppose we want to determine the workout activity, then it would be a definite activity and not a continuous thing. So suppose you are having some kind of movement, it would be either swimming or running. It cannot be in the middle of the two. So that is why it cannot be regression and it is classification. Is that clear, Rohit? In regression, we could have answers. Regression could be used where we could have answers in between as well. Then this is a very classic example of identifying. Rohit says, thank you, clear. All right. A very classic example of identifying famous landmarks in a photo. So this is definitely a classic example of classification. Next, moving ahead, suggesting spelling corrections. What do you think this should be falling on? So this is an example of clustering, and understand it from the way that we form a cluster. So suppose in a cluster we have similar words. Say we have cat and we have all the words similar to that. But if you say, suppose type COT, then there would be a cluster where we would be having similar words which have different, very minor differences in one or the other characters. So it will see from that cluster and find you the nearest correct pronunciation or the correct word that could be there for your word that you have typed. So actually clustering is being used here. So then next say suppose we want to estimate the arrival time based on time of day and traffic. So here it is an example of regression, as we could have time, even it could be like 10 minutes, it could be 11 minutes, 10.5 minutes, and so on. That is why we have regression here, because we need not have a specific time that it could be 2 p.m. or 3 p.m. We could have a continuous time. That's why we have regression here. So suppose we know the climatic conditions of the day, the traffic or the traffic jams that are there on a particular route, and we can predict the estimation of the arrival time, and the regression algorithm is being used here. And similarly, if say suppose we want to translate between two languages, this is definitely an example of style transfer, as we have discussed earlier also. Now moving ahead, we have a basic idea of some real life examples of machine learning problems and various algorithms that we can use to solve them. So, is machine learning really required to solve this problem? This is one of the question that should come in your to your mind, and you should definitely ponder upon before solving any of the problems. So, definitely, machine learning is a very trending topic and very trending field and a buzzword nowadays. So, it's like very crazy to talk about machine learning and see that you have applied machine learning in this or the other thing. But one thing that we need to ponder upon is that we should first make it clear whether machine learning is actually required or not. So we could have either the rule based approach where we write simple programs as we write in C++ or Java. We write, if this is there, then this could be done, else this could be done, and so on. So, in case we are able to solve some problem using some rule based approach, then we should definitely not move to machine learning, as machine learning itself involves lot of overheads. We need to have better computation power, better data sets to train our models, and so on. So, suppose, say, for an example, we want to predict whether a student is pass or fail. So, here we could simply go by the rule based approach, as we know that if marks are greater than 40%, which is a threshold, then the student is pass, otherwise fail. We need not apply machine learning here. We could even solve this using machine learning, say we could apply some algorithm and then predict, but we don't require that. So if some problem is easily solved using rule based approach where we have defined rules, then we should definitely go by that approach and not move on to machine learning. Yes, so this is one of the very important thing to keep in mind, that don't directly jump onto machine learning to solve any problem. First, make it clear that whether machine learning is actually required or not. So let's see a few examples. So now suppose, tell me what approach we should use when we are alphabetizing a list of song titles. So we are given a list of titles of songs and we need to alpha- keep them in alphabetic order. What should we use? Should we go by the rules based approach or machine learning? Yeah, Rohit is saying to repeat the problem. So basically, you are given, say, a list of song titles and you want to sort this list in an alphabetic order. So should we go by the rules based approach or machine learning approach? Akash is saying rule based. Aditi saying rule based. So yes, all of you are right. Here we can simply apply some sorting algorithm to come up with the alphabetized or the sorted list of titles, and we need not apply any machine learning algorithm to do this task. It can be easily done by a rule based approach. Say, next, we have the problem of predicting housing prices based on location. So we want to predict housing price, and we are given some parameters, say suppose location, and there could be some other parameters as well. So based on location, we could determine some parameters like transport connectivity to that location, the weather conditions, average weather conditions of that locations, and so on. So what do you think should be the approach here? Either we should go by rule based approach or machine learning. Yeah, so we even discussed this just few minutes back. It is an example of machine learning because there could be, we cannot have a definite answer based on rule based approach for this problem, as we might encounter different conditions. Now suppose we have some location and it has some different transportation facilities. Similarly, we could have another location which might have very different transportation facilities. Similarly, the two could have different climatic conditions. So we have various factors to ponder upon, and we cannot go by the rule based approach to predict the prices, whereas machine learning would give us a better response. So this is an important problem now. We need to process online payments. What should we go by? Rule based approach or machine learning? Do think before answering. So we need to process the online payments. So you could consider the case of any e-commerce website or any online transaction that you do. Should we go by rule based approach or a machine learning approach? Yes, all of you have answered correctly, that we should definitely go by the rule based approach, because in machine learning we have some instances where we could have wrong predictions or wrong outcomes. We have a certain accuracy in every machine learning project that we do, and it is not necessary that it would be 100% every time. So but in case of a situation like online transaction, we cannot afford to have any wrong predictions or wrong outcomes. Thus, we need a definite set of rules. That is, we need to go by the rule based approach, and that's right. So, we use the rule based approach here. Now, suppose we need to classify an object in a photo. So, we discussed this earlier as well. So, this is a classic example of machine learning. Now, there is a quick activity for you guys to understand and see the application and understand the importance of data that we have, data sets that we have in machine learning algorithms. You could go to this link, that is g.co/quickdraw. This is a game made by Google called the Quickdraw Game, and you can try it out yourself as well. So what you get here is, once you click on let's draw button, it gives you something to draw, and then gives you a particular time set, and then you need to draw this in that particular time set. So similarly, it will give you six such figures, and say suppose now we get this sword. So try to draw whatever you get, and it will also tell you whether you have correct made it correct or not, so that here it guesses the correct sword. And similarly you do for all the six figures that you get, and I'm fast forwarding it to show you what the outcome Yes, you can definitely give it a try, and it is a very good and fascinating thing made here. So at the end, it also shows you how many of the things you got correct and what were the right predictions made by you, how you made this drawing was correct or not. So this is something you can do in your free time, but we are not interested in the game, but rather we are interested in its implementation. So let's have a look. So this is the game Quickdraw with Google.com, where you can play this Quickdraw game. And here it is Quickdraw with google.com/data. Don't worry about the links. We'll share all these links in the description of this video as well. So this is the link for the data sets. And here we have 50 million drawings kind of, and over 15 million players have contributed to millions of drawing. And this is how this data set has been formed. So you could see here different objects, and if you hover over anything, you'll see what each object is, and then you could say if you want to know about more about Apple. I hover this object and I click on this, and then this opens for me all the images that it has in store for the Apple. So as we can see here, we are looking at 1,39,898 Apple drawings made by real people on the internet. So basically, what Google has done is we have a collection of a large amount of images for each of the objects. So these many users have drawn these images and labeled them as Apple on the internet, and Google has collected all of them. And now, based on these, so it trains its model based on these images and then asks you to draw the apple. And if your image is near to any of these, so if it gets your image and it can make it out that this image belongs to an apple, then it gives you the prediction accordingly. So for each object, you can see here these kind of things. So suppose I want to go to this alarm clock, and then I see that here we have 1,13,910 images of alarm clock. So these are the different alarm clocks made by people. So this is how this game works, that it has a large data set of each of the objects, and then it asks you to draw the some object, and then it finds whether you have made it right or not. So do try and have a time with this game and also ponder over this data set. It will be a great insight. So now once we have seen this, we have also seen this quick draw data. Let's see how crowdsource comes into the picture. So being a crowdsource influencer means that you are contributing to the Google's mission of making machine learning easily available. And so this is how you contribute. So these images have been contributed by some real people and labeled by some real people, which are helping now to solve some problems. We have a reliable data set which we could use in our upcoming projects. So the Google's mission is to organize the world's information and make it universally accessible and useful. So this is how crowdsource helps in this mission. And so we know that artificial intelligence is everywhere now. So suppose this is a very good example. We have something written in some different language. You use some app and it converts it to your language. So now when you are traveling internationally, you don't understand some specific language, their regional language, not to worry. Use the app and you can translate anything into your own language and understand it. So, but now suppose when we search for Google Photos and we search for the images of bride, you'll see images like these, but you'll hardly see images like these. That is, we have image of a particular region, that is of the, you could say the previous image could belong to say US, where AI and machine learning are used on a very extensive scale, and say this image belongs to an Indian bride which is not using this app or not having this information and using it on such a large scale. Similarly, if you want to find pictures of pancakes, you'll easily find that, and Google Photos will easily recognize that as a pancake. On the other hand, if you want it to recognize the picture of paneer, which is a very common dish in our Indian tradition, it might not be able to recognize it so easily. So Rohit has asked, is this data open source? So yes, Rohit, that the data shared there over Google Quickdraw is open source, and we'll share those links in the chat as well as I presented on the screen. And now let's have a quick view of some figures. So we have 9 million images in open images dataset. This is given by Crowdsource, which helps a lot of budding engineers, ML engineers to work on and a reliable dataset as well. And out of these, only 3% images are from India and China. So that's why we have this kind of marginalization here, that we in images we have the pancake very easily available, but paneer is not that easily available, because in the data sets that we have, a large amount of data is provided from that region, but from this region, say suppose India, we have less than 3% of the images. So this is where crowdsource comes into picture to solve this problem. So we can solve this problem when we have an equivalent number of images from all around the world to train the machine learning models. This would also help prevent the biases that we get in the machine learning models, because each language, each region should have the equivalent advantage. Now, why crowdsource? So, crowdsource, we have Android and web app which allows users to answer quick questions in a gamified user interface. And so you'll have a various images here, a large number of images, and you could select the category so in which you want to classify the images, and then you won't just have to rate whether, say suppose you choose the category of flower, then you just have will have the images on your screen and you'll have to say whether it is a flower or not. Similarly, if you have say a boat, you just need to classify whether it is a boat or not, and then based on your responses, this will help generate training data sets for machine learning. So in a way, if you are contributing to crowdsource, you are in a way helping in creating better training data sets for machine learning. Now, how to contribute? We Once you go to the app or the web app, you'll have various ways and you'll see how you can contribute to this thing, to crowdsource and contribute indirectly to the training data sets of machine learning. And we have presented this in great detail about crowdsource and also how to become a crowdsource influencer in one of the previous videos, which was streamed some days back. So you can have a look at that as well. Apart from that, we have this image label verification, where you just in this activity you'll have images and you just need to verify whether it is that image or not. Then we have handwriting recognition, and you need to type what is being presented on the screen. Then we have translation, you need to translate from one language to your regional language. Then we have translation validation, where you need to validate whether it has been translated correctly or not. Then we have image capture, where if you are a photographer and interested in photography, then this is for you, where you could capture images, and if you love traveling you could capture images and put them here. This could also be counted as your contribution to crowdsource, and this helps in making a big difference, as we saw that we could have something, this project called Quickdraw. Similarly, we have many such projects, and all the more these data sets could be used by machine learning engineers for the upcoming projects, which could be of great help. So the photos have a very great impact. And just to count on the numbers, we have around 480,000 images of everyday objects and people released as an open data set in December 2018. So this is how Crowdsource is helping the open source community, that we have this amount of data, which is definitely a huge amount, contributed to open source, which could be now used by anyone and everyone for their training their models and for any of their upcoming projects. And also, it if you are contributing to Crowdsource, you are connected to a very big community globally, and you could get help from the global influencers and connect with them, share your thoughts. And also, if you are making contributions and stand out, you are given awards. And we have local influencers. You could connect with some of your local influencer to see how you can contribute. Also, you should download this app from Play Store or web app and start contributing to Crowdsource, as this is a great thing. You'll have a great learning as well as you have a great contribution to the data sets in machine learning. So this is more about Crowdsource, and we have some useful links here. So let's have a look at them as well, and we'll share all these links in the video description as well. You can move on to there. So this is Crowdsource. You can read more about Crowdsource, how it is helping. So this is about the Open Images Extended, that is the open source data set that has been created to help the global community. And if you want to know more about Crowdsource, you can move to this website, and or you could contact any of the influencers and get connected and know how it works. And this is a very interesting tool. If you are interested in machine learning, you want to learn about this. So this is called as A to Z of AI, that is basics of machine learning. So for every character from A to Z of the English alphabet that we have, it gives you a word which is related to machine learning in one way or the other, and it also defines and explains it. So as you might be knowing about neural networks, it shows what neural networks are. It defines in a very interesting and a beautified way. And similarly, if you are a very beginner, you could should definitely go to this resource. And these are like 26 basics, you can say, of machine learning. For each character you have something, and you could know about them, read about them. And this would be a very good start for machine learning and or artificial intelligence if you want to move to. Another resource which I would like to share is this teachable machine prepared by Google. So in this, you get to train your models. You could have models based on images, voice, or some basic existing projects. And here you don't need to write any machine learning algorithm yourself. It is done everything on the back end. You just need to add some of your pictures, click some of your pictures, and it trains your model on the go. So do try it out yourself as well. This is also a great tool. So if you don't have the knowledge of machine learning, of writing the codes, writing the algorithms, but still want to feel how machine learning works, how you can see it working in real sense, then you can move to this link and definitely try this out. It is a great resource. So we have all these resources and we'll be sharing these. So that's all from my side. And at the end, I would also like you all to fill this feedback form, that is bit.ly will also have the link, bit.ly/yt hyphen feedback for the particular session that we have had just now. And also, if you are willing to receive updates for such amazing opportunities for college students, like the different programs, then definitely go and fill this feedback form to receive future updates. And that's all from my side. If you wish to connect with me, you can connect with me on LinkedIn or follow me on Twitter. And you could read about my works on Medium. I've written about my internship experience at Mintra, a very detailed blog there. So do give it a read. Or you could also, if I've written a blog on Kubernetes, that is a very recent technology of DevOps. If you are interested in that, do give it a read and go there. So that's all from my side. I hope you like the session and do give in your feedback. So I hand it over back to Seema. Thank
Thank
you,
you, sir.
everyone.
That was indeed very informative and a great session. So now we'll start with the second session, which is Introduction to Scikit-learn, Hyperparameters, Model Validation, and Feature Engineering for Machine Learning. And we'll be using Azure notebooks for it. Before starting with this session, let me know if there's any problems with the stream so far. I hope there aren't because I was looking at the stream myself as well. And do let me know if you have faced any issues so far. If you have faced any issues so far, you can just put it down in the comment section. I hope that there were no issues that you faced. So I guess yes, there were no issues. So before starting with my session, I'll just thank you again to Sachin for such a great session. And if you've liked this session so far, don't forget to leave a like and subscribe. And now let's begin with the second session. So before beginning with the second session, I want to introduce you to Azure Notebooks. So what is Azure? So Azure is a Microsoft cloud service. So about which you can read about at docs.microsoft.com. Azure Machine Learning. I'll just open the docs. You can see you can read about it here. So basically, what is Azure Notebooks? Azure Notebooks are an online platform where you can run your machine learning modules and you can learn about Python. You can actually, it is more than just Python, it is used for various things. And this is a general GitHub repository where you can learn about it. You can get examples on DSVM. And next steps, you can start with the sample notebooks here and then Azure ML examples. Right. So Azure is by Microsoft, is their cloud computing. So when we talk about Azure ML, let's talk also about Azure Notebooks. So when I open Azure Notebook, you'll get this link, notebooks.azure.com, which of course you need some credits on it. So if you're a student right now, you will get $100 free credits to start with. I have currently exhausted mine. So today I'll be using Google Colab instead, right? And they're monthly credits, and sadly this is the last of the month, all right? So right now I'm using Google Colab, and we'll be learning about sklearn, just scikit learn, right? And then about hyperparameters, right? And then we'll be learning about feature engineering for machine learning. So without wasting any time, let's just start learning about Sci-Kit. I've already prepared a notebook. So I hope that you can see the notebook correctly. Do let me know if you're unable to see or if there's any issue. I don't think there has to be an issue. Let me just check it as well. So yes, because there's no issues. So let's just start learning about scikit-learn. So basically, what is scikit-learn? So let's just start reading a little because once we don't read anything, we don't learn anything, of course. So there are several machine learning libraries which provide a range of machine learning algorithms. Scikit-learn is one of those. It provides data sets. It provides a lot of models to fit and predict. Right? So you can read this once. You can pause if you want and read this out. I'm going to simply move on and you can come back again as well. So move with me. That is preferred. So before beginning with anything, so I'm going to import Cbon as a SNS, which is Cbon. So Cbon is a library which is in pandas, which is in Python, right? You can install it by using this command in your command prompt. Before using this, of course, you need pip. So you can write this command pip install Cbon, and this will help you install this library. Mine is already installed, so I don't need to install it again, right? And if you're using Google Colab, it is pre-installed even on Azure Notebooks. So pre-installed on Azure Notebooks if you use that, right? So you can definitely look at that. And Iris is basically a variable that I'm taking in SS load. So Iris is a data set that I'm loading. So in Iris data set, there are some species of flowers and information about that particular species is given, right? So you can see that this table is from the Iris data set. Now this is basically what? This is a features matrix. this is what I call a features matrix, right? What is the features matrix? A features matrix is simply a matrix that contains some information about anything. So here, this is the information about flowers, the sepal length, sepal width, petal width, and the species. Sorry for that. So yes, this is the convention that we are going to use in the entire notebook. So n samples will be the total number of rows as mentioned here, and n features will be total number of columns. So I hope that most of you know what are rows or columns. So these are rows and these are columns. Sepal length, sepal width, petal length, they are the columns, whereas 0, 1, 2, 3 are the rows. All right. So that is about the basic introduction of what kind of a data set that we're using. So this data set is present in the Sci-Kit Learn library. All right. And so this is, we are going to plot these features against each other. So we're going to see some patterns. As my petal length increases, this is the differences of sepal length for these kind of species. For Setosa, we can see blue. For versicolor, we can see orange. And for Virginica, we can see green. So these are various types of, I'll just zoom into this graph. So you can see that with an increase in sepal length, these are the kinds of flowers that have this kind of sepal width. So on the y-axis are these parameters, and on the x-axis are these parameters. All right. So these are the plottings of. This is just to get an overview of the kind of data we have in Sci-Kit. Right. And in the next step, we're going to see what are the shape of it, what is the size of it. So the shape of the iris data set is 150, 5 originally. We have already dropped the final column, which was species. You can see here the last column was species, so we have dropped it right now. We'll train our model to find out the correct species. So to train it, we have dropped this and we will keep it as a label. So now we have 150 rows and 4 columns, and we can see that I have loaded this species column into my y-iris. So this y-iris I have one is now one column and 150 rows. All right, with only species, with only the names of species, which will work as a label. All right, so that's about the data set that we're going to work with. So let's now look at their estimator API. So you can see that these are the various parameters or principal guidelines that the Sci-Kit parameters work upon. Their consistency, that all objects share a common interface drawn from a limited set of methods. Inspection, limited object hierarchy, composition, sensible default. Let's learn about what these are. Inspection is specified parameters which are public attributes. What this means that we'll have to inspect like what feature affects the final result, how much, right? So on the basis of that, we'll get the final result of which flower belongs to which species, right? We'll just see this while working onto the Scikit-learn, so you'll learn it on the go. Don't worry. Now let's talk about the basics of the API. So this is the steps that we need to follow. We have to first choose a model. So there are some models like linear regression, logistic regression, and there's naive Bayes, there's KNN. There's so many various classifiers that we can choose from. And in the last section, Sachin also discussed some of the other important parameters that we can use. And this is choosing model hyperparameters. So hyperparameters will look ahead in detail, right? And then we have to arrange the data into the correct order so that we can fit it onto the model. See, every model, predefined model has its set kind of data type it's going to take as an input, a set kind of parameters it's going to take an input. So we need to arrange our data in such a way. So when we talk about arranging our data, we've already discussed that in the webinar that I held some time ago, where we had talked about how to arrange your data. So it was discussed when we discussed about Power BI as well, right? And then finally we called fit, and then finally model. So even if you don't know how to change your data, don't worry. You don't need to go back to that webinar right now. You can go back to that later if you want, because right now we're not going to use that. Any part of it that we're going to use, I will explain. We are going to be focused more upon Scikit today, right? So see, this is the kind of data we have. We have generated a random data to we learn about linear regression. So what linear regression does is that when we have data this sort of, you can see that this can be plotted onto a line, right? A line can be passed there such that each point, the sum of difference from the points that lie on that line versus the place of these points. So let me write down the difference between the actual point versus the position on the graph. So how does this work? So if my line is some, let's say y is equal to 2x plus 1, right? So for x equal to 2, what is my value? My y value for x equal to 2 is of course y is equal to 5, right? And suppose this is my prediction. Suppose this is prediction, all right? And what did I need to find? Where was my actual y was? Suppose 5.2. So the difference is 0.2, right? So we write this algorithm such a way that we have to minimize this difference. So that is what linear regression does. All right. And for that, we talk about decent gradient, descent, etc. We've also had a webinar on linear regression as well in detail. You can check that out if you want. In the meantime, don't worry, linear regression, I'll explain what it means, and while we continue, you'll understand it. Right. So if we draw a line here, so let's see how we can do that using Sci-Kit. How can we predict this using Sci-Kit? Right. So this is there from sklearn, which is scikit-learn. So that you don't get confused, sklearn is scikit-learn. Right. We import linear regression, which, as I mentioned the name, right, that is linear regression, and then model equal to linear regression, fit intercept equal to true. Right. What does fit intercept mean? Fit intercept is a hyperparameter that we need the right intercept upon the y-axis. So when we write down this equation of a line, which is y is equal to mx plus c. So here, what is c? C is the intercept. C is the intercept. So to find that, we need to fit on the relation, find the right intercept of this line as well. Otherwise, it will keep it as 0. Right. So first of all, I've taken a random data, like from n samples and n features. I've taken this and I've printed x dot shape. All right. So this is, I've taken a data which is of which has 50 rows in one column. Right. It was this data that is plotted over here, 50, which has 50 points, and then I run model dot fit. So what is, and then after model has been fit, it will get fit. What does fit is doing? Fit is actually uh, find training the data, training the model. Sorry, training the model on the given data. All right. So this trains my data. It does not predict yet. It just trains it. So model dot coefficient is the slope, and model dot intercept is the intercept. So in y is equal to mx plus c, right? Coefficient is m, coef is equal to m, whereas intercept is equal to c. All right. So that is what it is. So we have found the intercept and the coefficient of this line that we're going to predict. Right. So to fit it, and we need to check this data, right? Now, how to check this data? That whatever line we have predicted, how accurate it is. So I've created this sample where I've taken random points which vary from this included -1 to 11. So you can see that this is the array printed. This is the xfit array. So what np.linspace does is it creates some random points along a line. All right, from the given range to the next range. So now we fit this with the uh, with the new axis, and we fit the model, and then finally we predict. So y fit is what? Right? Y fit are predictions. Y fit are predictions, while x fit is testing data. So we use x fit to train it on y fit. So we feed x fit to it and make some predictions, and then check it against y fit. So when we see, when we plot this, we get this straight line. As I mentioned, that we'll be getting a straight line. So you can see this straight line will be the most accurate straight line which satisfies these points. So this learning was linear regression. Now just talk about next kind of learning, which is generally supervised learning, and we're going to use naive Bayes for it. So don't worry if you don't know naive Bayes. Don't worry, we don't need naive Bayes, of course. You're going to be using Gaussian NV, right? So first of all, what we do is that we divide our data. So x iris is going to be x train, y iris is going to be x test, right? So we've divided our data into X test, X train, Y train, and Y test. All right. So this is just splitting our data. So out of the total data we have, we need some part of it which goes into training, which goes, and some part of it which goes into testing, because both the stages are important. So I simply see these are the standard lines. I define the model in previous step, which was linear regression. I fit it, and then I take a model and predict on it. That's it. That's all it takes in it. And we can see we can import accuracy score, and this gives us the accuracy of the model. You can see how accurate it is, right? Even though this is very naive classification algorithm, because it's a very simple algorithm. It doesn't use many heavy calculations or anything. It's a very, very basic algorithm. And even that algorithm is giving 97% accuracy. Right. And now we'll talk about PCA. So what PCA is, PCA stands for Principal Component Analysis. So don't worry, we don't need to learn about PCA in depth, but I'm going to tell you. So what we do is that project our data, we project our data onto different axes to determine the best variance. All right. So we judge this upon variance using using a matrix, right? Uh, right. So we do that using a matrix. Yeah, I'm forgetting the name of the form. We reduce it to a particular form. It's just not coming back to me, right? You might know we generally study that form. We reduce a matrix into its normal form and all. So when we do that and we project our data points onto that line, we judge the best line which satisfies most points. And to do that, we use PCA. And what PCS does is that it truncates the features which are not needed. So suppose you're driving a car, right? Now you want to judge whether two people are who is the better driver. So it won't matter there, right? That how good do they ride a bike, or how good they write, or how good they sing. These parameters, when given about a person, are useless to judge who is a better driver. So these kind of parameters we can ignore. So that's why PCA is useful. It ignores those parameters which have no effect on the final result. All right. And we can see here using PCA, we have classified them. You can see that is classified quite well. That all these flowers in blue are setosa, all these flowers which are in orange are versicolor, and all in green are virginica. So PCA, I have just done nothing. I've just taken out PCA in one step. Iris PCA equal to x of 2d, iris PCA2 is equal to x of 2d of 1, and then I've plotted this. That's all I've done, and you can see that it's giving a good result. All right, they're not overlapping a lot. You can see a minor overlap over here between versicolor and virginica, but the overall accuracy, considering that number of points, the accuracy is over 95%. And now, one more thing that is interesting to see is about how does this work on unsupervised learning, right? So for unsupervised learning, we're going to be again using Gaussian model. So you can see the steps again. This is basically just defining the model, and this is predicting the model. Oh, sorry, fitting the model, which is training it, and then ultimately predicting it. Right. That's all I've done in this as well. And I use iris of cluster is equal to this my model GMM, which is Gaussian mixture models. Right. And then I plot it again with PCA. That's all I'm doing. If you just want, I'll just run this there again. Right. Okay, I'll just recheck this. I think. All right. GMM is deprecated. Right. Okay. Y is not specified. All right. So I will just check it later. But yes, this also does give a good result. So moving on, this actually is the more important part, where we'll be learning about image prediction using sklearn, where we'll be checking hand digits. So you'll be given gestures made by hand, one, two, three, four, etc., and you have to tell the number the hand is depicting. So first of all, digits equal to load digits. This is again predefined data set in the sklearn, right? For data sets, it is predefined, and you can find out images. And so the shape of those images are this. I'll just show you the images below. So these are the images, right? At zero, you can see 0, 0, 0, 1, 1, 2, 2, 2, 3, 3. So there are various different images, and total images are 1797, and each image is in 8 by 8 matrix, right? So you can see the shape here, 8 cross 8, right? This is just plotting the this, and then x dot shape. So each x is 64. So the dimension of each x is 64. That's what here is. And then again, see, we can see just directly when we fit it into ISO, into manifold ISO map. So that's the kind of data we are receiving. This is the data, all right? And now let's try and predict it. So from sklearn, I'll import naive pies, again a very naive algorithm. And then when we fit it and find out the accuracy, we get 0.83, which is a decent accuracy. This is 83% actually, right? But only checking the accuracy is not enough. We need to check where we were wrong, how wrong we were. So for that, we will plot it into a confusion matrix. So confusion matrix, you can see here, we give true value and predicted value. So we can see that true value is for 2, when predicted value is 8, which is wrong because we had to predict 2. So this is the one of the mistakes that this algorithm has made. So we've also got result about how accurate it is overall, about the actual mistakes we've made. So that is quite effective, right? Using confusion metrics is also present in sklearn. So you can see I have zoomed it in. So for 8 again, when I was given a true value of 8, my prediction of 1 was quite high. It was 6, right? When I was given 2, my prediction of 8 was high. It was 15. And whereas the correct prediction was very low. So this is one of the results that is affecting my result a lot. For 4, a lot of predictions were made it as 7. So these are the kind of mistakes that this algorithm has made. But the overall accuracy again, it above 83%. So you can also do that. So now next part is actually judging the hyperparameters. So let's talk about hyperparameters. So hyperparameters helps us in judging what model to use, what are model parameters, and then fit it and use the model to predict labels for new data. All right. So from again, I'm loading the iris data set first, and this time I'm going to use KNN classification. So in KNN classification, what it does is that I locate a point and then I check the nearest points to it. So if I have three different classes, 1, 2, and 3, I'll find out which points in which class are closest to my current point, and then I'll classify it into that particular class. All right. So I've done this. So don't worry, KNN, you don't need to. We're talking about hyperparameters here. So again, I've done nothing. I've done same steps that I've been doing: model.fit and model.predict, and the accuracy score here is 1.0. It is 100% accuracy for this data set using KNN. KNN is again very basic algorithm. One of the algorithms which are said in machine learning that if your model is not predicting better than KNN, then your model is useless. That's what is said. All right. So from sklearn.cross validation, I import test train split. So here that x1 is now my x test data. Sorry, x1 is x train, x2 is x test, y1 is y train, and y2 is y test. So x test is data of x that I will be used to train this model, and x2 is to test this model. So when I predict it, it's again 90% accuracy again for this as well. So basically, where does hyperparameters come into play over here? Right. Let's look at that now. When I've taken hyperparameters, I'll leave out some hyperparameters. So suppose from an array, sklearn or cross validation, I've gotten this matrix. So it means that some of these values are affecting the result a lot, which are affecting as 1, 1, 1, 1. Whereas for zeros, they do not affect the model as much. All right. So these hyperparameters I can leave out. And when I talk about the means of the scores, that is 0.959. Now let's talk about selecting the best model. Right. There are several possible answers, and how should we move? We can use a very complicated model. We can use a very less complicated model. We can gather a lot of training samples, or we can gather more data to add features to each sample. All right. So getting more data, getting more training, getting using a very complex model. Sometimes some of these techniques are very useful, but sometimes you'll find some of these techniques will not be as good as possible. All right. So this is some mathematics that you can skip the time being. So let's just talk about this. So when we talked about linear regression, now I'll show you a data. So consider this kind of a data set, right? Now this data set, of course, cannot be predicted using linear regression, right? We need something a bit more complex, because for linear regression, you see this blue line is for linear regression. Of course, this line does not satisfy the given condition. It is impossible to find out this kind of a data using linear regression, right? So instead, what we'll use is called polynomial regression. So in polynomial regression, we get this kind of line. So what polynomial regression does is that it is similar to linear regression, because of course it is a regression classification, and in this it is regression predicted, I'm sorry. And in this model, we do the same thing, except instead of straight lines, we look at different kind of curves, right? But this of course is a bit more complex than linear regression. It takes more hyperparameters, it needs more parameters to predict ahead, right? Now whereas you see this, if you don't have the right hyperparameters, your validation score will reduce drastically. Even if your training score is moving up and giving you a good result, your validation score is reducing drastically, because it can sometimes overfit. That this line that we have predicted is not giving us the correct answer. It's moving monotonously. Right. So that's one of the drawbacks of it. Right. You can see this again. Of course, this could not have been done with linear regression. So I've used polynomial regression over here. So polynomial regression gives us a polynomial curve, which is this curve you can see. Right. And now let's talk about learning curves. So more important aspects of a model complexity is that the optimal model will generally depend on the size of the training data. For example, let's generate a data set with a factor of 5 more points. So I have 200 points over here and I've plotted them, right? So when we hear this important thing that we talk about median, and we talk about mean, right? So when I take the median of these scores and then feed that into the data, we will see that it has changed a lot. So you can see, while initially our validation score was drastically going down, in the new median data set, our validation score is not going down. All right, it's not coming up as much, but it's not going down either. So that is important. That is where you need the right set of hyperparameters. Which kind of data set you need to send, what kind of data you need to send, that matters a lot. All right. So that's about hyperparameters, right? You can do grid search. We have discussed grid search in the previous webinars, so I'm not going through that again. And now let's talk about feature engineering. So basically, when we talk about feature engineering, as I mentioned earlier, that we need to send the right kind of data set, right? So consider this data where I've talked about some hotel rooms which have this price, these many rooms, and this is the neighborhood where this particular hotel belongs. Right? It's very tempting to see that instead of making neighborhood as Queen Anne or Fremont as Queen Anne, I could have given it a number one and made Queen Anne as one, Fremont as two, or Wellingford as three. But where is this wrong? Right? Because numbers can be subtracted. Numbers can be subtracted. But text or string should not be subtracted that way, because they do not have that kind of a relation. So as mentioned here, mapping Queen Ant like this would mean that Wallingford minus Queen Anne is equal to Fremont. So you can see Wallingford is 3 minus Queen Anne is 1, which is Fremont. So this is not valid, right? So this should not be done. So that is why we do not generally take them into account as 1, 2, 3, 4. We take these things as a different column, as a different parameter, which here is neighborhood. So this is the part of feature engineering, about how my feature should be engineered to get the best output. Right. So that's what we're doing in this array as well. So when we get this feature names, we get neighborhood as this, we get neighborhood as queen, and then we get price and then room. That in this vicinity, this is the price and this is the number of rooms that we're going to get. All right. So you can see this again. Sample, this is problem of evil queen or horizon problem. We're going to look at some text features. So when we extract from text, we vec.fit transform sample. Right, the result is a sparse matrix recording the number of times each word appears. So you can see evil appears twice. Right, in the zeroth word it is appearing once, so evil one. In the first word it is appearing once, so evil one, and horizon is appearing once only in the last, and so on and so forth. You can see that different words are appearing how many times in each string. That can be done using pandas, right? So basically, now let's talk about some image features and derived features. So yes, you can see here, now this kind of a graph, when we talk about this, again cannot be predicted by linear regression. So see, if we try and predicting it by linear regression, This is the kind of line. Not even a single point is correct, neither is it close. So obviously this is wrong, right? So we will use, of course, as I mentioned, polynomial regression, and which gives us a prediction like this. But for polynomial regression, our data set needs to be correct. So all of these data sets will not exactly satisfy it. Some of them will be missing. So like in this, you can see there are some missing values. There are null values. So how to fulfill these null values? We can fill them by mean, we can fill them by median, or we can randomly put some values. So here I've used a strategy mean. This is a simple code to it, inputter, and strategy is equal to mean im.fit transform x. So where there were none values, they have been replaced by the mean values. So in the first column, there's 4.5, and the next value is replaced by 5. So first of all is the mean of the overall matrix, and for the second value, the value which I have added into the matrix is also taken into consideration as well, right? So where it was taken 0 initially, now it is taken 4.5, and there are these values, and so it becomes 5. All right, and you can see now when we try and breaking it, this is the kind of array we get. These are the points that we get ahead. All right. So feature pipeline is not. I'm just going to discuss it in a very brief manner. So when we import pipelines, you can see that we have to make a pipeline that first of all my data should be predicted using polynomial regression, and then I should get a matrix which should give us the results which are more optimum. Now these results can lie on a linear regressional curve, right? So for them, I can use linear regression. So first of all, my data goes through a polynomial regression, and then it goes through a linear regression. So this becomes a layering sort of process. All right. So that is what pipeline. And with that, I think I'll end my session here, and we'll move on to learning for IoT. So Sambhav, can you hear me?
Yes, I can.
All right. So I'll hand it over to Sambhav, who will be discussing about IoT, Arduino versus IoT, and Raspberry Pi, and importance and needs of IoT. All right. So Sambhav, you can please take over now. And if you liked my session, don't forget to leave a like and subscribe to the channel. And handing it over to Sambhav now. Thank you.
Good evening, everyone. My session is about IoT. What is it and why should we care? The internet has been around for a while, but it has been mostly the product of the people. So before moving on to IoT, this is our agenda. I will be talking about what is IoT, the need for IoT, applications and benefits of IoT, such as in everyday life, healthcare systems, smart cities, and disaster management. A brief about technicalities such as IoT ecosystem and its layers. And finally, I will be wrapping up by giving a brief comparison between the two microcontrollers, Raspberry Pi and Arduino. Moving further, the internet has been around for a while, but it has been mostly the product of the people. So all the data, the images, the recordings, games, books, and commerce, and all of that was created by people, for people, and is about people. You see, the internet is one of the most important and transformative technologies ever invented. It is like a digital fabric that's woven into our lives in one way or another. Now, there's new internet emerging and it's poised to change the world again. This new internet is not just about connecting people, it's about connecting things. And so it's named the Internet of Things, popularly called IoT. Now, connecting things to the internet is a big deal. This is because things start to share their experiences with others. How is it done? You take things and then you add the ability to sense and communicate. This is because you get an opportunity for things to interact and collaborate with other things. So think of it like this. We as human beings, we interact and collaborate with other people in our own environment through our five senses. We are seeing, smelling, hearing, feeling, and tasting. Now imagine things with the ability to sense and to touch, and then add the ability to communicate. This is where the Internet of People and the Internet of Things intersect. So, what are some examples of these things? Well, one of them is our smartphones. You wouldn't believe how many senses your smartphone has. It knows your location, it knows if you're moving, it knows how you're holding it, it knows how much light's in the room, it knows how close it is to your face. It knows what you're saying to it and even has an eye in the form of a camera to see its surroundings. Not to forget that it has the ability to communicate on a wireless network. Another common example of a thing is a thermostat. So this is the need for IoT. We still had devices to perform tasks for us before IoT, right? Then what is the difference with or without IoT? The difference is that you had to run from one device to another, telling them what to do before IoT. This guy will run from this device to this device to this device and tell all the devices what to do manually. However, with the Internet of Things, the devices can interact, collaborate, and learn from each other, just like just like us humans do. They will learn from each other's experience just like humans. This is ultimately aimed to reduce human interventions in the machine cycle. The machines are in continuous touch with each other, as we can see in this figure, and can be pre instructed on what to do and when to do. Not just that, these machines can even adapt to your needs and modify how they function. Moving on to the applications of IoT, the Internet of Things equips a multitude of things and millions of devices with connectivity every day. The few most interesting of them all are IoT in everyday life, IoT in healthcare, smart cities, and disaster management. First, we have Internet of Things in everyday life. This is probably a hallmark in the IoT industry, as it is the first industry to deploy it at its service. Let me give an example how IoT can serve us in our daily lives. Consider a home appliance such as an air conditioner. Currently, what you do is you go home, turn on the AC, and then wait for it to cool your room to a temperature suitable to you, say about 20 degrees Celsius. Now consider the same situation, but what if when your car is 5 minutes away from your home and your AC receives a message? What if it was connected to a cloud which had a dashboard containing all the relevant information like the location of your car, the outside temperature, and your temperature preferences? Your AC could then turn on suitably before you arrive and create an ambience that suits you. It may be hard to believe, but all that what ifs are now a reality thanks to IoT. All of this is possible now. Now, IoT can connect your Fitbits to your vehicles, from your smartphones to in-flight services, from home appliances like ACs to whole entire cities. Basically, this is an environment where every area, sensor, man, and machine are connected to each other, as we can see in this figure. Online shopping, wearable technology, smartphones, cars, home lighting, smart cities, music, personal computers, analytics, insight services, all of these are connected to each other and can interact and experience about each other. I'm sure a few of you have heard about the smart medical dispenser by now. As the name suggests, it is basically a smart appliance that stores, dispenses, and manages medicine for you. This is a very small piece for a very large picture. The healthcare and the general practice of medicines majorly faces issues in one or more of these three things: no real time data available, lack of smart care devices, inaccurate standard analytics. IoT in healthcare, so medical research has to rely upon leftover data in controlled settings for medical examination. It lacks real world data which can solve critical conditions. IoT can be the answer to all these problems. IoT opens a gateway to a sea of real time data through analysis and real time testing. It thus empowers healthcare professionals and improves the quality of healthcare. Most importantly, it significantly reduces the cost of medical appliances. This is basically an outline of how a healthcare device works. A care device has certain parameters that are considered safe. Once one of them is breached, the sensor immediately relays this message via a secure gateway to a cloud. Now, it is vital for this gateway to be secure as it holds valuable personal medical records. The cloud then passes a remote signal to a smart device that is monitored by a healthcare worker. The beauty of remote patient monitoring is that patients can now replace a long wait at the doctor's office with a quick check in, data share, and instructions on how to proceed. IoT hence reduces the gap between reading devices and delivering healthcare by creating systems rather than just equipments. Now, a thing about smart city is that a smart city solution is very specific to that very city. For example, problems faced in Delhi are quite different from problems faced in Mumbai. Even global issues such as waste control, traffic management, availability of drinking water, housing, and pollution impacts different cities differently. So the only way to really make a city smarter is to cater specifically to its problems. One such problem, common to most of the urban cities, is traffic. So imagine an intelligent device like a traffic camera. A camera that can monitor roadblocks, accidents, rainfalls, etc., and communicate that status to a gateway. Now, this gateway also receives data from various other cameras all around the city. This in, cell, in, this in itself would form a citywide traffic monitoring system. Now, where can we use it? So, let's say the municipal corporation has decided to repair a road which connects to a highway for more than one city. Now, this can cause massive congestion. A smart camera can send this insight to the citywide traffic system. Now, considering it as a smart camera system, it quickly learns and predicts patterns in traffic. It will analyze the situation, predict its impact, and relay this information to other cities that connect to the highway via their own monitoring systems. This information can be used to derive routes for cars around the construction area. Live instructions can be sent to drivers via radio channels and their respective smart devices. So, this brings me to the final application for today, disaster management. Now, IoT cannot stop disasters from happening, but it surely can help in preparedness and resilience during one. Due to high population density, poor evacuation infrastructure, and exposure to several weather conditions, developing countries are more exposed to the risks of natural disasters and often have limited means to sustain the effects. IoT can compensate for this by prediction, preparedness, response, and recovery. So, taking the example of a disaster, for instance, forest fire. To be prepared in advance, sensors are installed near the perimeters of the forest. They contribute data feeds about temperature and carbon emission to a control room, which is common to the entire room. This is done via a secure network gateway in real time. In case the data indicates risks, they anticipate problems and mitigating measures like police, nearby hospitals, and fire brigades are immediately started. So, all of this, what is IoT? Why do we need it? What are its benefits and real world applications have been covered. In future sessions, we'll look into IoT features, architecture, and ecosystem, cloud computing, fog computing in IoT, and much more. Before finishing, I'll quickly give a brief comparison between two famous microcontrollers used in IoT, Raspberry Pi and Arduino. The computers were a breakthrough in the world of machines, making the operation of any device smarter than ever. And the motherboard in the computers is what drove these operations in the first place, either performing logical instructions fed to them or calculating outcomes based on information received. Now, these motherboards are integrated circuits, and with the world trying to minimize the size of such devices and make them more portable, we now have a variety of similarly capable circuit boards available. The smartest of these circuit boards zero down to these two, the Raspberry Pi and the Arduino. The Arduino is based on a microcontroller and is mostly designed to control the electrical components connected to the circuit board in any system, whereas the Raspberry Pi is based on a microprocessor that computes data and produces valuable outputs, and if required, it controls the electrical components in its systems based on the outcome of its computation. So the Arduino, it is designed to control the electrical components. It is a microcontroller, whereas the Raspberry Pi is an entire computer within itself. Basically, the Raspberry Pi is a single board controller, while the Arduino is just a single board microcontroller. So the Arduino being more of a microcontroller motherboard, it is best suited for repetitive tasks like reading and reporting temperature, opening and closing of doors, controlling lights, or building motion detecting alarms. It also works great in lightweight prototypes. But the Raspberry Pi is more like a general purpose computer and is good at complex calculations, performing multiple tasks or processing a large amount of data. I hope you guys enjoyed learning about this cool technology. Thank you. I'll be handing this over to Simant.
Thanks, Ambaf. That was indeed very informative, very great session. Thank you, Rohit, for the positive feedback. So I hope you all enjoyed the session today and learned something new. You can always check back the channel for more informative sessions, and you can press the bell icon for further sessions. And don't forget to leave a like and subscribe. I'll be coming back soon with more sessions with amazing lineup lined up for future with some great videos, great interviews of people in various fields and in development. So on that note, tuning out today, thank you for joining. Please come back soon.